Aloha, Rich Halverson here. This is ICS235, and in this video I'm going to do lab 10.8. So in this lab we're doing training options for neural networks, and so we're going to look at the diamonds.csv dataset again. It contains these features, among other things. And so we're going to create a data frame X that contains all the features except these things. And then we're going to create the Y data frame from just price. And we're going to first we're going to define a standardization scalar and apply it to XTrain and XTest. And then we're going to initialize a multi-layer perceptron regressor using this one, MLP regressor. And then we're going to, with some parameters here, and then we're going to print out the R-squared scores. And if we use this random state instead of this random state, we get these numbers, but actually we don't. I think this is wrong. Anyway, doesn't matter because you can submit as many times as you want until you get it right. All right, so we'll start out here. Initializing the libraries and stuff. We're going to use do we use this? Oh yes, we do. Right down here. We're going to use this model, and we're going to use a scalar here. Okay. So, and by the way, we learned about scalars. These things in chapter 6. If we look at you look back to this feature transformations used in chapter 6, this lab here is where we first see this define a standardization scalar to transform the values. See, chapter 6 is model improvement, feature transformations. Right. Okay. So anyway, okay. So we start out by creating reading out of the diamonds.csv file. It's this thing here. It's got a bunch of features, a bunch of instances. So we're going to start by creating X. X is going to be everything but these four. See, so it's this drop. And Y is just going to be price. And then we're going to split X and Y into training and testing. And we're going to split them up this way. And we're going to use this random state, and the reason we do that is so if we're going to test it over and over again, we get the same set of random numbers. Okay, now here we're going to define a standardization scalar to transform the values. So we can do something like this. Copy. Paste. Control V. And then we need to do something like for XTrain, we need to do something like this. Copy. Oh, except for it's train. So I just need this part. Well, okay, it's fit transform. Okay, so this is equal to standard scalar dot fit. First fit it, then transform it. XTrain. Okay. Now XTest, we've already fit it. So we only have to transform it. So we use this use this standard thing we just created here, this standard scalar dot, and we're only going to use transform x test. Um, so this is actually the same as see this fit transform in all of the past examples, and we use this standard scalar. We use this fit transform method in lots of labs, but it's actually the same as this. We could do this. And just do the fit. And that fits the model. And then we use transform twice. That works too. Same thing. I think this is the first time we've seen transform, so that's why I just did it this way. In all these other cases, we're actually doing those two functions, just those two methods, one right after the other. You can this. I think you could do this. I think that works. Two, 8, 5, 6. What's the last one? 2896. 2896. 144. Yes, okay. Anyway, yeah, so that's just a little bit of education there. Okay, so we've done that. We've applied the scalar. Then we have to do this ML this MLP regressor. Um, it's this thing right here, this thing. So I'm going to copy this, go down here, and we want this with some arguments. And one argument we want is, let's see, let's start this out. Random state. Well, that's just random. That's okay. So we're using, go back to section 10.1, multi-layer perceptrons. We're going to use this random state. Copy this. So the first, I'm going to put it on the line by itself. This is going to equal, it's supposed to equal 42. And then 3 hidden layers of 50 nodes each. So here, hidden layer sizes. So we're going to do something like this, but it's going to be not this. Copy. It's going to be 50, 50, 50. Yeah, 3 of 50, 50, 50, 50. Okay, comma. What's next? Adaptive learning rate of 0.01. That's, go over to 10.2. Training and tuning multi-layer perceptrons. And we're going to be doing learning rate of 0.0. I'm going to copy this. A learning rate of, ooh, I didn't mean to do that. Come here. Okay, a learning rate of 0.01. comma, learning rate is adaptive. Don't forget that. Learning rate is adaptive. That. Okay. And then we need batch size. Is that one? That's oh, here we go. Batch size. Copy. Batch size equals 100. And maximum iterations. Max iter equals 300. Okay. So that's my multi-layer perceptron regressor. Okay, now we've got to fit the model. So that's simply MLP diamond dot fit, and it's the training data. X train, comma, NP rabble, Y train. Okay, that fits it. And then we're going to write the scoring thing. Score for the training data. Well, by now we should just know that it is MPL diamond dot score parentheses X train, comma, Y train. Yeah. And this one would be MLP diamond dot score parentheses testing data X test, comma, Y test. Okay. And I think that's pretty close to all that we need. So, well, we can try to run it with this 1, 2, 3, but I kind of don't 1, 2, 3. I don't think we get these numbers here. At least when I was fiddling around with it earlier, didn't seem like it. 8632, no. 875, no. Well, I tell you what, I'm just going to put in the 42 like we're supposed to, like it's supposed to be. And then I'm going to submit for grading. And I got all the points. So there. All right. So that's lab 10.8, and I think I've shown you how to do 4. So you only have to do find 4 labs that are not in the ones that I made videos for, and just do those. And so the ones earlier on are, of course, are the easier ones, and you just got to find the Jupyter example that helps you along. So if you have any questions, just email me, and hope this helps. Thanks for watching.